Assalamualaikum and salam sejahtera to all my panel. My name is Muhammad Muhammad Kamsari. Today I would like to present my final year project, which is the implementation of deep learning and motion control using drone. For introduction, gesture-based interface has been applied in many things. We can see it in our smartphones. It requires a gesture to tap, to scroll in order to control the smartphones. The gesture-based interface also has been evolved to a new level, which is it require no touch by using the lip motion sensor. The lip motion sensor is an electronic device that used to sense the human gesture using infrared scanner and the camera. The lip motion has been developed from 2014 and until today, and now it's currently developing and evolving to make it more precise. Drones or unmanned aerial vehicle is an aircraft that requires no pilot and is widely used in filming, military, and educational purposes. There are several problems that are found in order to create this project. The first one is the remote control limits the motion and control to perform a specific task. You can see that nowadays an RC controller have the limit patterns in order to control movement. We cannot modify it easily. And then the second one, the drones require a specific controller to perform a flight. The specific controller, once it's broken, we need to buy a new one. You cannot just program it and then easily create a new one. There are several papers that I found control drone using a hand gesture, which is using glove, and some of them are mostly not provide more stable control system using hand gesture. And for the last one, some drones camera are not able to apply object detection because the camera and the drone itself has been separate and not in the one system. That's why the camera is cannot to apply object detection. For my objective, I want to implement all the possible hand gesture movement that can be detected with the lip motion sensor and implement the hand gesture recognition using lip motion sensor to control drone, to provide more stable controlling system using lip motion sensor that interact with drone directly, to evaluate the performance of drone in terms of frame rate with image processing. The scope only consists where the area the drones can be controlled using lip motion sensor via Wi-Fi coverage provided by the drones, and the drones will be controlled using lip motion sensor, which only hand gesture is included to give any instruction. Several tests will be conducted in order to evaluate the performance of the developed system. And lastly, object detection purpose only for testing the capability of the drone's camera. For my literature review, there are several papers that I review, and I'm going to make a summary for the comparison. Okay, for the first paper, they are using the Kinect sensor and versus my project, which is using the lip motion sensor. The Kinect sensor used to detect whole body motion, and however the lip motion sensor only detect hand. As I used to apply to a drone only, I recommend to use only lip motion sensor, which is more suitable in order to just control the drone. For the next paper, they are using DJI Phantom 2 and my project using DJI Telo EDU. As we can see that the DJI Phantom 2 is quite expensive, however they have a lot of advantage and a better performance. So in order to just complete my project and apply it to achieve my objective, I just only buy the DJI Telo EDU to complete my project. Okay, the third paper, they are using projector interaction, and my project uses the hand gesture detection. As you can see, the project interaction have a bit disadvantage where the interaction is quite hard to detect when it's in a bright condition and the sunlight condition. For my hand gesture detection, it can detect whether in that condition, since it have infrared, and it might be more accurate when in light condition because the camera can detect the hand to provide more better accuracy. Now I'm going to proceed with what method I use and the item need in order to complete this project. Now I'm going to proceed with the block diagram of the system architecture. There are three stages, which is input, process, and output. For the input, I'm using the hand gesture, and the process, I'm going to use my laptop with the software of Visual Studio 2019 with the Python language, and the output is drone itself and the object detection captured by drone's camera. Okay, the flowchart starts by system initialize for computer, loop sensor and drone, and then the hand position on top of the loop sensor in order to loop sensor detect the motion, and then is it the hand tracking by motion sensor is detect. If no, go back to the system initialize. If yes, goes to the computer recognize the hand gesture. The computer send the signal to drone for the execution. Drone is also retrieving the video and process using YOLO version 3 for object detection. This is a big example of the YOLO version 3 object detection that I used in order to apply object detection. Now go to the further result and discussion. For my system overview, we can see that here is my laptop, loop sensor and the drones. Okay, for takeoff and land movement, I'm going to use the counterclockwise rotation, which is I use my finger. For takeoff, I'm gonna use clockwise rotation, and for the landing, I'm going to use counterclockwise rotation. Okay, for the movement, the rotate right and rotate left for the drones, I'm going to use the yaw position, which is the right yaw will rotate the drones to the right, and the left yaw, the drones gonna rotate to the left. Okay, for the move forward and move backward, I'm going to use pitch movement, which is the upper pitch will control the drones for the forward movement, and the lower pitch drones gonna move backward. Okay, for move right and move left, I'm going to use roll movement, which is for the right roll. The drones gonna move right, and the left roll, the drone gonna move left. Okay, let's proceed for the demonstration video, and we can see what happened to my project. After the demonstration video, you can see that YOLO version 3 timing object detection has been successfully applied to the drone. The line chart here shows the FPS comparison of YOLO version 3 object detection for 2 tries. There are 2 conditions that I put here, which is drone is in ideal condition and drone is in flying condition. You can see that the FPS produced for the first try is around 3.8 until 6.2, and then for the second try you can see that the FPS produced is around 6 until 8, and then goes to the maximum FPS, which is around 8.0 to 8.4. But I can see that here drone is in ideal condition quickly reach the highest FPS within 10 seconds compared to the drone is in flying condition for the both try. Time goes to hard cascade phase detection. The line chart here shows the FPS comparison within 2 tries when drone is in two condition, which is ideal condition and flying condition. We can see that when we are using the hard cascade, the FPS start in high value and then drop a bit after 10 seconds where it's in stable condition. We can see that within 2 tries, both of them are produce a similar FPS, but however, the FPS reach fast stable condition when the drone is in idle condition compared to the drone is in flying condition. For a conclusion, the leap motion has been successfully applied to the drone. Most of the drone movement has been successfully replaced by the leap sensor. However, there are some issues with the SDK file, which is cited on the release for 2.7 and not Python version 3. The early SDK, the latest SDK, help in solving the problem with detecting the gesture and the hand movement at the same time. The object detection of YOLO version 3 and hard cascade face detection successfully retrieved the video from the drone. However, the YOLO version 3 cannot suitable to connect the leap since the leap only support Python version 2 and YOLO require Python version 3 and above. The frame rate of the drone's camera drops when the object detection is applied. The performance of the drone shows the temperature rising high when applied object detection. For a recommendation, I would like to suggest to change the language for this system, which is use the C++ or C#. To get the latest SDK for leap that provide more accuracy hand detection and more gesture can be produced for drone movement. I would like to suggest a better drone, which is DJI Mavic Pro, to replace the Tello ED drone for a better battery life and a good camera resolution. Next, I would like to suggest to use a better performance of a computer with higher graphic card for good object detection and recognition. Okay, for future works that might help in order to improve my project, I would like to recommend to use our smartphone and put additional hand detection, which is only 2 items required, which is the drone and the smartphone only to control the drones. The smartphone use the hand gesture in order to control the movement of the drone, but however, it requires a lot of testing in order to detect the hand gesture, since the comparison between the leap sensor and the smartphone, which is the smartphone doesn't have infrared sensor in order to make it more precise to detect the hand gesture itself. That's all from me. Thank you very much.